JKSSB series. Yes, so as I promised before, that will be conducting session, okay, for the TSPSC AE examination, and also many students requested for JKSSB JE also. So we'll combine the sessions and conduct a session such that all your examinations are covered. Yes, and we know that GATE is an examination which you prepare. If you prepare for GATE examination, then other examinations like state AE and your state JE and other examinations are also taken care, because the syllabus of these examinations is less than equal to that of GATE. But we need practice sessions, yes, for these examinations, and therefore we are conducting the practice sessions. So welcome Afreed, Krishna, Juhi, Sri and Vivek. Okay, good morning to everyone. Yes, so we'll start the session. Before that, a short introduction about myself. This is my short introduction. You can go through this thing. Yes, then coming to the scholarship test. Okay, many students were asking me that okay, some problem happened here. Just 1 minute wait, there is some technical error. I am just 1 minute. Yeah. Now it is done. Yes. So we are having this scholarship test for all the students. Okay. So those who want to take up the full course, okay, for that we have this scholarship test being conducted. So the next scholarship test is on 24th of December, 8 p.m. So interested students, okay, because here we are mostly conducting practice sessions and some concept sessions we are conducting, but it is not possible that we cover the entire, you can say, concept series here. Yes, therefore the full courses are available on the BYJU'S Exam Prep app. Okay, so to access those courses you need subscription. Yes, so for that, to help the students who are meritorious, so this particular scholarship test is being conducted, so you can register for the scholarship test. The link is in the description. Okay, let us go to more things. But as some more series were also starting, we are going to start this grand marathon series from your 3rd of January. Okay, because GATE exam is there, so we will be revising all the major concepts in this marathon series. Okay, so let us start with the questions. So everybody is able to see me. So today we will solve how many questions? Any guesses? Any guesses how many questions we are going to solve today? Any guesses? Please write in the comment section how many questions of RCC we will be solving today. Any guess? Please do some guesswork. 40? More? I want to listen to the students. 45? We will be solving 100 questions. We will be solving 100 questions. Okay. So we will be solving 100 questions. Okay. And all these 100 questions will be beneficial for all your GATE examinations. Yes, 150 will be too much. Some other day we will cover more 100. Yes, so 100 questions we will be covering. This is for, you can say, TSPSC, AE and AEE. Yes, students are appearing for JKSSB JE. So for that also, because 15 questions will be asked from, 15 questions will be asked in this, and here you can expect 10 to 15 questions. And for any upcoming your state PSC examination, see, even if it is UPPSC or MPPSC or OPSC or any exam, civil engineering won't change, na? Yes or no? It's not that the shear force and bend moment diagram will be different in UP and different in Andhra Pradesh. No. Yes. Or the deformation of bar will be different. No. Yes. So any state exam you see, it will be same. So if so that's what I'm telling, that any public service examination you are targeting, these sessions will definitely help you. And I have decided that every week, at least once or twice, I will be conducting these sessions so that you get an idea of the questions. First of all, you get the questions, most probable questions. Second thing, you get practice. And third thing, you understand that which things I should focus for the examination, right? Okay, so we'll start the session. Yes, so since 100 questions we have to solve, you have to be little fast, right? You have to be little fast then. Yes, so let us start. Okay, first question on your screen. Come on, answer the question. Read the options and answer the question. Okay, I'll just shift little bit here because it is interfering, right? Okay, this side I'll shift. Please tell the answer to this. You have to do very fast, okay, because all these things will be one minute, 1 mark, or we can say in half minute you should be able to solve. Yes. Okay, if the neutral axis is below the neutral axis it is cracked, the shear stress distribution is how? It looks like this, right? Till neutral axis it is parabolic and then constant till where that matters. Till where that matters. Up to the tension steel. Up to the tension steel. That is important. Yes. See this B option. It is written up remaining depth. No. Up to the tension steel. Means what? This depth is how much? This depth is effective depth. Yes. Answer is D. Next question. The diameter of longitudinal bars of RCC column should never be less than, or I am asking you the minimum dia of bars in column. Minimum dia of bars in column. What is the right answer? What is the minimum dia of bars in a column? Yes, it is 12 mm. Very good. Next question. The minimum percentage area of tension reinforcement in beams if Fe 500 is used. So if Fe 500 is used, what is PT minimum? The percentage is asked. PT minimum. What is PT minimum? Tell me what's the answer to this PT minimum. What is PT minimum? Yes, 3B, C, C. Yes, it is C. Remember the formula is what? 85 by Fy. The formula is 85 by Fy. So if it is Fe 250 steel, you divide it, if it's Fe 250 steel, you get how much? You get 0.34. If it is Fe 415, you get approximately 0.2. And then if it is Fe 500, you get how much? You get 0.17. You see half of this, na? Yes, because you see 85 by Fy. So if it is 250, you are getting 0.34. For 500, you get what? 0.17. So answer is C. Next question. In shear design of beams, check for your maximum shear strength. This tau c max is required. Why? This is the maximum shear stress or maximum shear strength. So why we check for this? And what is the check we do? The check we do is that the nominal shear stress should be less than this tau c max. Yes. So why we do this check? Why we do this check? Why we do this check? Yes, we do this check for possibility of crossing due to diagonal compression. Due to diagonal compression. You see, if tau v is greater than tau c max, then what will happen? Then beam will fail. Beam will fail in diagonal compression. In diagonal compression. Yes. See, we have a tau c also, na? Tau c. Tau c takes care of what? For diagonal tension. So remember this. Tau c is for what? Diagonal tension. The tau b should be less than tau c. Otherwise it will fail in diagonal tension. And tau c max is what? Is for diagonal compression. Next question, question number 5. Yes, direct question. Flexural collapse in over reinforced beam is due to? In over reinforced beam. Come on, you have to be a little fast. You are going a little slow. In over reinforced beam is due to what? Come on, fast. Over reinforced beam. Which type of failure occurs? In over reinforced beam. Yes, it is primary compression failure. See, in over reinforced beam, what happens? First concrete reaches 0.00535 strain and crushes, right? See, the first it crushes. First is crushes and then second what happens? And second steel yields. Second steel yields. Steel doesn't yield actually. Before that only concrete fails. The first thing is that. So first means what? Primary, na? First means what? Primary. Therefore, primary compression failure. Secondary compression failure occurs in under reinforced beam. It occurs in what? It occurs in under reinforced beam. Why it occurs in under reinforced beam? Why it occurs in under reinforced beam? Because under reinforced beam what happens? First what happens? First steel yields, right? So first steel yields, yes, and then second what happens? Second what happens? Second concrete crushes or concrete fails, we can say in that case. Concrete crushes or reaches is 0.005. So this is what? Yes, this is fails in compression only. Concrete fails in compression only, but this is second thing which is happening, na? Here also fails in compression, but this is the first thing. So first means primary, here the second thing, therefore what? Secondary. Understood this concept? Question number 6, very straightforward question. Partial safety factors for concrete and steel respectively are. Partial safety factors for concrete and steel respectively are. Partial safety factors, very straightforward question. Yes, the answer is A. Ladies and gentlemen, this is the answer for limit state method. Yes, and this is the answer for what? This is the answer for working stress method, right? And since nothing is mentioned in the question, so default you will take what? LSM only. Default, if nothing is mentioned in the question, LSM or WSM, limit state or working stress method, you will take what? LSM only as the default thing, okay? Nothing is mentioned, LSM, this is the answer. If you write WSM, then C is the answer. Question number 7, come on, fast. The maximum allowable stress, tau C max. This tau C max which we discussed, which is responsible for diagonal compression failure, it depends on what? It depends on what? Grade of concrete, grade of steel, both. On what? It depends on what? It depends on what? It depends on what? Answers, many answers people are telling. It depends on only grade of concrete. It is tau C max, it is not tau C. So its formula is approximately 265 root FCK. This is the approximate value. This is the approximate value, okay? Approximate value, and therefore it only depends on grade of concrete. Tau C is different. Tau C will discuss later. Tau C is different. This is what? Tau C max. The maximum allowable. Tau C max. Okay. Next question. Question number 8. Very straightforward question. Flexural strength of this. The flexural strength is also known as what? Modulus of rupture, right? Very straightforward question. Flexural strength. The modulus of rupture, or we can say FCR. What is the formula? What is the answer? Very straightforward. 3.5. 0.7 root FCK. 0.7 root FCK. So 3.5. Very good. Next question. Question number 9. Okay. The maximum strain in concrete. The maximum strain in concrete at the outermost compression fiber in the limit state method design of flexural member. What is the maximum strain in concrete? Yes, the answer is what? 0.0035. And it is irrespective of grade of steel. Any grade of steel, any grade of concrete, this is the failure strain. So I can say this is the maximum, or I can say failure compression strain, right? Failure compression strain. And this is for all grade of concrete and all grade of steel. So failure one will be the maximum one, right? Yes. Next question. Question number 10. Let's see. Come on, fast. What is this? Yeah, from columns. Structural member subjected to compression had both translation and rotation restrained at one end, while only translation is restrained at the other end. As per IS 456, the effective length factor. See, effective length is what? It is K into L, right? So this K they are asking for this boundary condition. What is K? For this boundary condition, what is K? How to solve this question? Very easy. See, first of all, you draw the column. Okay, what is written? Translation and rotation restrained at one end. Restrained means what? Not allowed, right? Translation is not allowed, rotation is not allowed. On the other end, translation is restricted. Translation is restricted, but rotation is allowed. Only translation restricted means what? Rotation is allowed. So this is what? This is fixed end, and this is what? This is pinned end. So theoretically, from theory K is how much? From theory K is 1 by root 2. That is how much? 0.707. But it is written as per IS 456, and as per IS 456, IS 456 tells that we cannot have 100% fixity. So they change to what? Increase it to 0.8. So answer is what? 0.8. Understood? Next question, question number 11. Please answer this question. The nominal shear stress doesn't exceed the permissible shear stress. Means what? When tau V is less than tau C. Yes. Nominal shear stress doesn't exceed the permissible shear stress. Then what you should do? If this is the case, what you should do? See, if you see the spacing is what? Spacing is less than equal to 0.87 Fy ASB, right? Then tau B minus tau C into your B. This is the formula for spacing. You see, when the tau V is less than tau C, that means what? The spacing will be negative, na? Yes? The spacing will be negative. This means what? Spacing is negative. Spacing is negative means what? Not required, right? Spacing is negative means what? Not required. But then code tells, even if it is not required, code tells that even if it is not required, you should provide the minimum shear reinforcement in that case. So even if your tau V is less than tau C, then also you should go for what? Your minimum shear reinforcement. Okay. Next question, question number 12. Okay. The minimum strain at failure in the tension reinforcement, or I can say tensile steel. Okay. So the yield strain, this minimum strain means what? Yield strain, right? So in the tension steel, what is the yield strain? Okay. If we have Fe415 steel. So basically they're asking you what? Yield strain. Yes, they're asking you what? Yield strain in Fe415. What is the answer? Please write in the comment section. What is the answer to this? Others, why many people are not answering? I expect all to answer. See, even if you feel that okay, I am answering correctly, but you should answer. This is 0.0038. Yield strain formula is what? 0.87 Fy by ES plus 0.002. This is the yield strain, right? Or I can say the minimum strain. You see, if you see the stress versus strain diagram, if with the stress versus strain diagram, you see after this yielding will start, right? The minimum strain, right? So this is the minimum strain which had to be maintained in the tensile strain. So this is the yield strain. This is what? Yield strain. Because after this, the yielding will start. So indirectly they're asking you what? Yield strain. And this is this formula. So this value is what? 2 × 10⁵. So if you put Fe415, you get this value. Yes. And if you put Fe500, if you put Fe500 means Fy is equal to this Fy equal to 500. So you'll get what? You will get this value as how much? 0.0042. Get 0.0042. But the same yield strain for Fe250 is what? The expression changes. The expression is what? Only 0.87 by Fy. And for Fe250, what is the yield strain? It comes to be 0.0011. Remember? So these three values should remember in the equation also. You see, this value for Fe250, this value for Fe415, and this value for Fe500, and the equations also. You see, this is the equation for mild steel or Fe250, and this is the equation for what? This thing. Understood? Let's go to next question. Question number 13. Okay. Design bending moment. Come on, fast. We are going slow. Huh? Fast, pick it fast. Design bending moment means what? To do load combination. So dead load is given, and live load is given, and seismic load is given, means earthquake load is given. So use the load combination. Okay. And they're asking limit state of collapse. Do the load combination and tell me what is the right answer. See, when you take these three loads, then how much you are getting? You will be getting 72, right? 20 plus 30 plus 10, 72 kN meter. But there can be another combination, right? Which combination? 1.5 dead load plus live load or earthquake load or wind load. Here wind load is not given. So to take what? Maximum of live load and seismic load. That is how much? Earthquake load. So we'll take 1.5 of dead load and live load. Right? So when you take this combination, you're getting how much? 75. The maximum one you will choose. So check all the combinations. Check all the combinations. Okay? Check all the combinations. Don't miss any combination. Yes? So getting 75. You see 72 was close, right? Next question. Question number 14. Okay. If the T-beam behaves as a rectangular beam of width equal to its flange width. Okay. So if we have a T-beam like this and it behaves as a rectangular beam only. It behaves as a rectangular beam only. Okay. Then what is the condition when it behaves like a rectangular beam? The condition is when the neutral axis remains within the flange. See, when the neutral axis remains within the flange, what happens? You see, if the neutral axis remains within the flange, then what will happen? This area will be under compression. Yes. And below that, whatever is the tension doesn't matter, right? Because below neutral axis, we don't consider the concrete. It is cracked. So you see, if we consider only the compression area, then the compression area is looking rectangular, na? Yes. With a width how much? It's a rectangular beam, you see. The compression area, it's a rectangular beam. Yes. It's a rectangular beam with a width of how much? Equal to the width of the flange. So answer is what? Remains within the flange. Remains within the flange. Question number 15. Come on. Shear strength of concrete means what? Tau C. Shear strength of concrete. Tau C. We have seen tau C max. Here they are asking about tau C. It depends on what? This tau C depends on what? It's a function of what? Tell me. Tau C is a function of two things. First, it is function of the grade of concrete. Yes. Second is the function of the percentage tension reinforcement. Tension reinforcement only. It doesn't depend on the compression reinforcement. So compressive strength of concrete, correct. Percentage of shear reinforcement, nothing. Third option is percentage of longitudinal reinforcement in tension. That is correct. Total, no. It doesn't depend on total, because when you say total, total includes what? The tensile percentage and the compression also, na? But doesn't depend on compression. It only depends on what? Tension. This is tau C. Yes. And tau C max is what? Tau C max depends only on grade of concrete. Okay. So these things, small things. So try to understand. Like these small things they ask you in the state examinations. Okay. And again I tell, if you are preparing for this, you are preparing for all exams, right? Okay. And these questions are also asked in ESE prelims also. It's not that in ESE. See, tell me, is the person who has cleared ESE or the person who is assistant engineer in UP or Andhra Pradesh or Telangana or Karnataka, are they studying some different civil engineering? Will the code change? Will the code change for, you are assistant engineer in Telangana, so you will be having different code. You are assistant in Karnataka, different code, or ESE, different code. No. So it's the same thing. So when you are preparing, this is, we can say, a more, so such kind of sessions will help you in have a more, and always target multiple examination. Don't only get attached to one exam. That is not good. Okay, now answer this question. The code matching. Okay. Some problem happened. Okay, it's appearing different. Okay, please answer this. Code matching. You should remember, I am telling you, at least 50 codes you should remember. Okay, 50 code, and for that their use you should remember. Okay, so I have given here 4. Okay, at least 50 codes, both, everything, aggregates, concrete, cement, everything. So what is the answer here? See, 875 is for loads, no doubt about that. Yes. 1343 is for your pre-stress concrete, and 1893 is for earthquake resistant structures, and 3370 is for water tanks or liquid retaining structures. So 2, 4, 1, 3. Yes, answer is D. Yes. The limiting depth of neutral axis, XU limiting, it depends on what? Tell me. The limiting depth of neutral axis depends on what? Limiting depth of neutral axis depends on what? Grade of concrete, grade of steel, both grade of concrete and steel. What is the right answer? Yes, it depends only on the grade of steel. What is the formula, by the way? XU limiting is K into D. And what is K? K, if you remember, it is, you can write two formulas. 700 by 0.87 Fy plus 1100, right? This is the formula, right? Yes, this is the formula for K. You can see only Fy, there is no mention of FCK, right? Or I can say here, another formula is what? 0.0035. Okay, then what? 0.87 Fy by ES. Yes, ES value is how much? 2 10 to the power 5 plus I'll write down little here. 0.87 Fy by ES plus 0.0055. So this is the formula. You can see that there is no mention of what? There is no mention of FCK, only Fy is there. Next question, question number 18. Okay, what is the adoptable maximum spacing of stirrups? Okay, what is the maximum spacing of stirrups? Come on, you have to be fast little, huh? We are going slow. What is the maximum spacing of stirrups? Okay, when the effective depth is 300. What is the maximum spacing of stirrups when the effective depth is 300? It is, yes, it is 225. 225. The maximum spacing is what? Minimum of two things, you forgot. This is 0.75D and 300, right? Yes. The minimum of these two, right? Yes. So 0.75D, effective depth is 300. So 0.75 into 300 is how much? It is 225. So 225 and 300. Minimum of these two will be how much? This will be 225. So answer is what? 225. Understood this? Small things. Yes. See, if they have not mentioned the effective depth, then we have to take 300, right? Because you don't have any option, right? Don't have any options. Yes, we don't have any options. If they have not given the effective depth, then 300. But they have given, na? So we have to take that into consideration. Question number 19, very straightforward question. XU limiting expression for FE415. Just now we discussed. XU limiting for FE415. Oh, C is writing फंस गया sir. So you don't get, नहीं फंसने के लिए we are attending this session, right? So if we are attending session, then we will not get caught. The answer is straightforward, 0.48D. Again, I am telling such kind of questions will be asked in the examination. So please attend these sessions. Okay, this is for FE415, right? For FE250 we get how much? 0.53D, and for FE500 we get what? Your 0.460. Next question, question number 20. Okay, fast. 20 questions in half an hour. We have to be fast. Okay. Which of the following comes under limit state of serviceability? We have two limit states, collapse and serviceability. So which comes under limit state of serviceability? Tell me what is the right answer to this? The right answer to this, B. Yes, answer is yes, B. See, in collapse what happens? Collapse, which limit states are coming? Flexor, means what? Bending. Then shear, right? Then compression. Then what? Compression, which is found in columns, right? Columns. And then torsion. These are what I can say the limit state of collapse, right? In serviceability we have deflection, cracking, durability, fire resistance. Yes, we have deflection, cracking, yes, durability, fire resistance. Okay, all those things in which the structure will not fail, but it will not be usable. Even lateral stability comes under collapse. Okay, lateral vibration also. Yes, vibration. Yes, I'll write down here. Okay, Okay, lateral stability level component collapse. Yeah. Next question, the spacing of rectangular beam. Good question. Please answer. I think the spacing, where it is increased, where it is kept less, where it is decreased. Please see and tell me what is the answer to this. Come on, the next, now it is 11. In the next half an hour we should be solving 50 questions. Okay, we are slow. Answer is D. Okay, you see, the spacing will be inversely proportional to the shear stress. Yes, the spacing will be inversely proportional to the shear stress, right? So shear stress is more where? Shear stress is more at the ends. Yes, shear stress is more at the ends. So here less spacing. Here less spacing. And shear stress is less at the center. So I can say more spacing. More spacing. So I can say increased at the center of beam. Next question, question number 22. Side face reinforcement or side reinforcement is provided in beam when the depth of beam is more than how much? Straightforward question. Side face reinforcement, yes, it's provided when? See, side face reinforcement means like this. You see, suppose this is a rectangular section. Then I can say this is the stirrup, right? And this is the tension reinforcement. Yeah, the tension reinforcement. This is the compression steel, right? Side face reinforcement is this one we provide here. So we provide this side face reinforcement when the depth is more than 750 mm. Okay, next question. Okay, maximum span to depth ratio for a simply support beam. Very straightforward question. Or allowable span to depth ratio for a simply supported beam. Very straightforward question. What is the right answer to this? The answer is 20. This is for a cantilever 7, right? For a cantilever 7, for a simply support beam it is 20, yes, and for a continuous beam it is what? It is your 26. Very straightforward question. Okay. Question number 24. Okay, which of the following losses is not found in pre-tensioned concrete? Which of the following losses is not found in pre-tensioned concrete? Yes, friction loss is not found in pre-tensioned concrete. So you see, first loss is elastic shortening. Yes, elastic shortening. Now elastic shortening, if we are doing at once, then yes, it is found in pre, but is found in pre but not found in post if we are doing once. Then if we are doing, see, when we are considering friction loss will occur in what? Friction loss will occur in only post. Yes, it will occur in only post, because when the friction is acting between what? Tendon and the concrete. So when the tensioning is done in pre-tension, there is no concrete, right? So it doesn't occur in pre. Same with slip loss also. Slip loss also occur in what? In post. It doesn't occur in your pre. But these are what? All short-term losses. These are what? All short-term losses, right? When we take long-term losses, what are the long-term losses? There are 3 long-term losses. That is what? The other things which are written here: shrinkage, creep, and what? Relaxation of steel. And what? Relaxation of steel. So these 3 losses, this occurs in both pre and post. This occur both in what? Occur both in pre and post. Yes, pre and post. And therefore, come on to all. Just remember that slip and friction loss don't occur in pre-tension. Question number 25. Okay. Okay, the design shear force for stirrups. This is known as VUS. Design shear force for stirrups, that is equal to the factored shear force minus the shear strength of concrete into BD. Because this is what? This is the shear capacity of concrete. See, whatever shear is coming on the particular section, some will be taken by the concrete, rest will be taken by what? The stirrups. Rest will be taken by what? The stirrups. Yes. So now tell me, what is the design shear force for stirrups. See, the total factors here is given 80. It is given 80. The shear strength, the permissible shear stress is given how much? It is given 0.25. And B and D are also given. You see, B and D are also given, right? So 230 into 350. But this will give me the answer in what? Newton, right? This will give me the answer in Newton, because you see Newton per mm square and then what? Mm square. So I'll divide by 10 to the power 3 to convert into what? Into kilonewton. So if you find the answer, approximately how much you're getting? You'll be getting 60 kilonewton. Why I put this numerical? Ladies and gentlemen? Why I put this numerical? Because many times you have to remember that in the examination, in state examination especially, that always they will not ask theory. Some 10-15% questions they will ask you straightforward numericals which can be solved within 1 minute. Yes, which can be solved within 1 minute, and therefore you should be prepared for such straightforward numericals also. Okay. Next question, question number 26. Okay. The maximum span to depth ratio, okay, for two-way continuous slab. For two-way continuous slab for FE 250. That means what? Mild steel. Tell me what is the right answer to this? Two-way continuous slab. Continuous. Yes. It is 40. It is 40. I'll tell you. See. In two-way we'll have simply support or continuous. Yes. See, in one-way slab, whatever beam follows, one-way slab also follow the same thing. Means what? 7, 20, 26. 7, 20, 26 is followed by what? One-way slab and this. Okay. One-way slab and this what? Your beams. But it comes to what? When it comes to your two-way slabs, then you have to see it is mild steel or HYSD. If it is mild steel or HYSD, for mild steel, the ratios are 35 and 40. 35 and 40. Yes, for mild steel. But for HYSD steel, what you will do? Just multiply this with 0.8. So this will become what? 28. And multiply 0.8, you will get what? 32. Yes. So if you remember this for mild steel, you indirectly remember for what? Your HYSD also, na? If you remember for mild steel, you indirectly remember for what? For HYSD also. Yes. So it is written first of all, C. Two-way, yes. Continuous, yes, continuous, and then mild steel. So answer is what? 40. Understood? 40. If the question was two-way simply supported, right? Two-way simply supported mild steel, answer would have been 35. Okay. Next question 27. Yes. In WSM, under wind and earthquake load, the permissible stresses are increased by, very straightforward question. Come on, fast. Come on, fast. We are only 27 question. Oh my God, we are so slow. I am explaining also, na? Okay, no problem. But let us make it fast. Straightforward, 33.33%. Question number 28. What is the minimum lap length? Okay, lap length means what? When you are joining two bars, you have to lap it. So the minimum lap length, okay, for bars under compression. For bars and in compression, what is the answer to this? Minimum lap length. Yes, it is 24.5. This should be minimum is 24.5. Yes. And when it is flexural tension, okay, or we can say the tensile bars in the beams, that is 35. That will be what? 35. Remember, means what? Suppose this is a beam and you are lapping the bars like this, it is what? It is 35. Okay, but in column it is 24.5 because columns are related to what? Compression, right? Yes. Next question, the critical section for shear. The critical section for shear for simply supported beam is at what distance from the face of the column? So if you have a simply support beam like this, and this is the face of the column, this column acts as support, then the critical section for shear is at what distance from the face of column? The critical section is at what distance from face of column? The answer is D. The answer is what? D distance. So this option is also D. The answer is also D. But D is the effective depth. D is what? Effective depth. Okay. Question number 30. You can see that how the questions are so nicely mixed that all your concepts are revised. Okay. Next question. No, but the two way you are telling, that is for footing, that is for punching shear, different thing. It is different. Okay. Okay. Now answer this. Okay. The maximum deflection, including the effects of temperature creep and shrinkage after erection of partitions and finishes, should not normally exceed what? It should not normally exceed what? Both A and B. Both A and B. Yes, A is correct. Both A and B. Remember this deflection limits. No need to remember so many things. When the right partition, this word partition comes, when there is partition and after partition and finishes, then we can say it will be what? It should not exceed means what? It should be less than equal to span by 350. Should be less than equal to span by 350. It should be less than equal to what? 20 mm also. Okay. It's both. But if suppose they are leaving cast level, when it is cast level, the deflection limit should be less than equal to what? Span by 250. So just search for these keywords. No need to go into ultra details of what is written. I always search these keywords. Question number 31. Okay, the side face reinforcement is how much? The side face reinforcement is how much? You have seen that side face reinforcement we provide when the depth is more than 750. What is the amount here? What is the amount we provide? Tell me. It is 0.1% of wave area. Yes, it is 0.1%. See, this is the total side face reinforcement. This is the total side face reinforcement. Yes. You distribute it. If see here the thing mentioned, not total is sorry. Here total is mentioned. If they write each face, each face will be half, right? Each face will be 0.05%, equally distributed, right? The not mentioned total means 0.1. 32. Okay, pretension. What is the deflection? Due to pretensioning force, there is deflection, uplift, right? So what is this uplift value? What is the center deflection for pretension members? What is the answer to this? This is PEL square by 8EI. Yes, where P is what? P is the tensioning force. The tensioning force. E is the eccentricity. Yes, it's the tensioning force. E is the eccentricity. E is the eccentricity. Okay, and L is your length, span I can say, and EI we know that modulus of elasticity and the moment of inertia. 33rd question. Okay, which of the following is valid for shear reinforcement? Come on. Shear reinforcement. Minimum shear reinforcement. I gave you the hint also in one class. I told that the spacing formula you will do some minor change and that will be the answer. I told that whenever this minimum one is asked, if you know the spacing formula, you do a minor change only in this. What I told? I told that in this tau b minus tau c take 0.4. Yes. So if you take this 0.4, you are getting this expression, right? Less than equal to what? This 0.4. So this 0.4 goes here. It becomes what? 0.4 BSB less than equal to 0.87 FYASB. See, anything, any ordering that do, you can answer, right? Any ordering that you can answer. 34th question. Minimum number of vertical bars in a circular column. Minimum number of vertical bars, circular column. Come on, fast. Come on, fast. You have to go fast. You got to go fast. Fast, fast. Come on. Come on. We are very slow now. How will complete 100 questions? 100 questions should complete in 80 minutes. Answer is A. Yes. For rectangular, it is 4, right? Let me speak fast. Rectangular, it is 4. Yes. Next question. Now time to speed up. The minimum grade of concrete for pre-tensioned concrete member. For pre-tensioned, what is the minimum grade? For pre-tensioned, what is the minimum grade? Pre-tension minimum grade is M40. Very good. M40. For post-tensioned, it is M30. For post-tensioned, it is M30. Post-tension, it is M30. Next question. Question 36. Okay, very straightforward question. Answer this. I explained sometime before. I told sometime before only, na? D span by 250. Cast level. Just search the keyword. 37. Anchorage value for a 135 degree bend. 135 degree bend is like this. What is the answer to this? Okay. The answer is 12 times. You see 4, 5 for every 45. You see this is 45 degree bend. So here it is 4, 5. This is 90 degree bend. So 9, 5. This is 135 degree bend. So 12, 5. Sorry, 9, 5 I'm telling. 8, 5. 12, 5. And then for 180 it is what? It is 18 pi. Sorry, 25. Sorry. 16 pi, sorry, what is happening? I am telling wrong things. So I can say 4, 5 per 45 degree, right? So remember like this, or per pi by 4 angle, right? Okay, next question, 38 question, come on. Lateral ties are provided in a RCC column, right? In RCC column we provide the lateral ties, okay? So why do we provide these lateral ties? What is the job? Why we at all provide these lateral ties? So there are many utilities of these lateral ties. One of the utilities is to hold the main bars. Yes, but what is the main thing? What is the main reason for providing this lateral bar? To avoid the buckling of longitudinal steel bars. Yes, that is the main thing. There are multiple reasons. Okay, there are multiple reasons, but the main reason is this. Yes, next question. The allowable crack width for mild exposure. Allowable crack width for mild exposure. What is the right answer to this? The allowable crack width for mild exposure. Allowable crack width for mild exposure. It is 0.3 mm. It is 0.3 mm. You see the options are in meter. In one exam this was asked, so therefore I put this question. Yes, it is 0.3 mm, or I can say 0.0003 meter. So be little careful of the units. Huh? So this is for mild. For moderate it is what? For moderate it is 0.2 mm. Yes, and for severe, very severe and other things, severe and above, it is 0.1 mm. Na? Okay, so read the options sometimes, don't get confused. Okay, read the options, don't jump. Huh? Sometimes read the options also. Next question. Crack width is controlled by what? Crack width is controlled by what? Crack width is controlled by what? Yes, by spacing of bars. By spacing of bars, the spacing, you see we have a lot of clauses for spacings. Those are decided by what? By maintaining the crack width within the permissible limits. The modular ratio of concrete, where C is the permissible bending stress in concrete in kilogram per centimeter square. Modular ratio, what is the modular ratio? Tell me. What is the formula? Yes, what is the formula? See, it's 280 by 3 sigma CBC, or here permissible bending stress. This is when the CBC is in Newton per mm square or MPa. Okay. If it is in kilogram per centimeter square, then this is the formula. Changes little bit. Remember, huh? Question number 42. In singly reinforced beam, the effective depth is measured from its compression edge to where? The effective depth is measured from where to where? Tell me. Very straightforward question, but you should, many students don't answer this. So, in a singly reinforced beam, the effective depth is from where to where? Yes, it is from, see, this is the compression edge to what? To the tension reinforcement. Not, there is no tensile edge is this one, right? There is no neutral axis. So neutral axis is depth of neutral axis, right? This is what? The effective depth, okay? So tensile reinforcement. Next question, 43 question. If the loading of a pre-stressed concrete beam or pre-stressed rectangular beam is uniformly distributed, loading is uniformly distributed, then tendon should be provided how? What should be the tendon profile? What should be the tendon profile if the beam is subjected to UDL? If the beam is subjected to UDL, what should be the tendon profile? Yes. So tendon profile is what? It is reverse of the bending moment. So bending moment will be parabolic. So this will be also parabolic with its convexity downward. Convexity downward, right? Yes. Why this is? Because you see the bending moment diagram will be parabolic. So it will be the mirror image of that, right? The tendon profile will be mirror image of that. So it is convexity downward. You can see downward. Okay. Next question. Question number 44. The Young's modulus of elasticity of steel, ES of steel. How much we take that? Very straightforward question. The modulus of elasticity of steel, which is taken in your IS 456, it is how much? What is the B? Yes, B. You see, this is 200 into 10 to the power 3 Newton per mm square. Okay. Or I can say this is what? I can say 200 kilonewton per mm cube. I can say like this. Mm. Actually, it should be mm square. It says units is wrong. Huh? We'll correct it. It is square. Huh? Yes. Square. Okay. Or it can be also 200 gigapascal. Na? 200 gigapascal. Na? Or I can say 2 into 10 to the power 5 megapascal. Na? See, many things they can write, right? Many things they can write. Same thing. But you should know. Yes, answer is this, B. 45. The minimum and maximum reinforcement in a column. Come on, fast. We are going very slow. Only 50 question. 50 question. Going very slow. Come on, fast. Minimum and maximum reinforcement. Answer is what? 0.8 and 6%. Minimum is 0.8 in columns and 6 maximum. Okay, good morning. The total shrinkage for a pre-tensioned member, pre-tensioned beam. What is the answer? Total shrinkage. Shrinkage strain means shrinkage strain for a pre-tensioned beam. What is the answer? It is 3 into 10 to the power minus 4, or I can write down what? 300 10 to the power minus 6. The answer is what? A. Answer is what? A. Yes, understood? Very good. The maximum spacing of main bars in RCC slab. Straightforward questions. The maximum spacing of main bars in RCC slabs. Directly straight main question. Very straight question. What is the answer? 3D. Yes. 3D or 300 mm, whichever is less. Right, but here nothing is mentioned about 300. So 3D. Question 48. Okay. Okay, if the beam is not provided with shear reinforcement, there will be shear cracks. So at the bottom, so that cracks is inclined at how much angle? Very straightforward question, right? So they would, if you are not providing the reinforcement, there will be shear cracks, or I can say diagonal tension cracks, right? Diagonal tension cracks at what? 45 degree, right? See, these cracks are known as shear cracks, or I can say what? Diagonal tension cracks, right? Shear cracks, or I can say diagonal tension cracks. Diagonal tension cracks, because the shear failure is not due to shear failure, it is actually due to diagonal tension coming due to shear. So 45. Question 49, straightforward question. Straightforward question. A? Yes, A. You see, sometimes they will, confuse you like this. See, this is the relation, but they're asking what? FM, na? So FM is equal to reverse of this. So answer is A. Question number 50. Okay, we have reached 50, but we are late. Come on, fast. Code used for mixed design of concrete. Code used for mixed design of concrete. Which is the right answer? As I told you, you should remember 50 codes names. Both highway and everything, 50 should, 50 code names. Answer is what? Mixed design. Mixed design is 10262. Okay, 10262. This is ductile detailing. This is ductile detailing. Yes. Yes. Okay. And the last one we know. Okay. A slab is 75 mm thick. The maximum size of reinforcement used will be how much? This is the total depth given. Depth of slab D, suppose. Depth of slab is D, suppose. And I am asking you the maximum size. Come on, you have to go fast. You have to go fast. We are going slow. We are going slow. It is what? You see, the maximum size should be less than equal to what? D by 8. It should be less than equal to D by 8. So, when I say 75 by 8, how much you are getting? You will be getting 9.375, right? You are getting this value, 9.375. So, it will be less than equal to this. So, obviously, it cannot be 10, it cannot be 12. And both 6 and 8 are correct. But they have written what? The maximum size. Maximum size out of 6 and 8 is 8. Next question. The strain in the compression steel. What is the answer to this? The strain in the compression steel. Come on, answer this. The strain in compression steel. Any idea, anyone? If you don't have idea, I will tell you, don't worry. B. See, this is your D dash. D dash means what? D dash is the cover, effective cover for the compression steel. Now this we can solve by your strain diagram. Okay, so strain diagram is linear, right? Strain diagram is linear, right? So you see, and this is 0.0035. Yes, this is 0.035, right? They're asking what? The strain in the compression steel means what? Over here. This you can easily find out, right? You see, what will be this one? This will be XU minus D, na? Minus D dash, na? XU minus D dash, right? So I can use similar triangle. I can write down, suppose this strain is compression steel, okay? So strain in compression steel, okay? See. So this strain by, okay, this XU minus D dash will be equal to 0.0035 divided by XU, na? Yes or no? Similar triangles. Similar triangles. Consider the bigger triangle. You see, bigger triangle and the smaller triangle, right? Okay. So from here I can say the strain will be how much? The strain will be, you see, XU by XU will be 1 minus D dash by XU, okay, into what? Into 0.0035. So answer is what? Answer is C. Answer is C. Understood? So you see, it's very simple, right? We can find out what? Using what? Strain diagram also. We can find out using strain diagram also. Very easy. Just D dash, you should remember D dash is what? It is the cover to, effective cover to what? Compression steel, right? It is the effective cover to compression steel. D is the effective depth. D dash is different. D dash is different. Don't confuse. 53 question. In pre-stressed concrete, what we do? It is advisable to use what? It is advisable to do what? It is advisable to do what? Tell me. Yes, both the grade of concrete and grade of steel should be high. Okay. 54th. Okay. The diameter of a longitudinal bars is 16 mm. Okay. So this I can say is what? The longitudinal bars have 16 mm. What is the diameter of the lateral ties? Should not be less than. Should not be less than means what? Minimum diameter, right? So I can say what is the diameter of the tie bar or lateral ties. What is the answer to this? See, lateral ties minimum should be maximum of two values. Maximum of two values. What? your 6 mm and your 5 means longitudinal bar divided by 4, right? This is the formula, right? So here 6 and this becomes what? 4 mm. So maximum of these two is what? 6 na. So answer becomes what? 6 mm. Understood everyone? Understood everyone? Yes? Yes. And remember, if you are getting confused between minimum and maximum, see, if this is minimum, this should be maximum. Remember this. If you see, what is maximum spacing? Maximum spacing is minimum or maximum of these two? Tell me. Maximum spacing is maximum or minimum of these two? Minimum, na? Yes. So remember every time, if this is maximum, this will be minimum. Yes. And this is minimum, this will be maximum. Understood? Now you will not get confused. Next question, question number 55. The neutral axis of a T-beam exists where? The neutral axis of a T-beam exists where? Yes, it is D. So if you are taking a T-beam like this, it can be within the flange, yes, it can be at the bottom edge of the slab, it can be below the slab, everywhere it is possible. So answer is D. That depends on many conditions we are not discussing here. 56. The torsion resisting capacity of a given reinforced steel section, what happens to this? Answer me. The torsion resisting capacity. Yes. See, torsion, we know that it will give rise to what? It will give rise to equivalent shear and bending moment, right? Equivalent shear and bending moment. Yes. So if you want to counter the bending moment, what we do? To counter bending moment, we have longitudinal steel, right? Yes. To counter bending moment, we have longitudinal steel. Yes. And to counter shear, we have what? Stirrups. We have what? Stirrups. So if you are increasing the stirrups, okay, increasing the stirrups, okay, and increasing the longitudinal steel, both the shear and bending moment capacity increases. Indirectly, torsion resisting capacity increases. Answer is D. Understood? It increases both with increase in longitudinal steel and stirrups. Okay. Next question, question number 57. The minimum value of minimum eccentricity for which the axial loads in column are designed. Remember this? Tell me what is the answer. What is the minimum eccentricity? Minimum eccentricity was, if you remember, L by 500 plus your D by 30, right? Or 20 mm, whichever is more, right? Or I can say maximum of these two. So that means when I am taking, suppose it is 30, then I will take how much? 30. If it is 18, I will take how much? 20. If it is 16, then how much I will take? 20. So can I say the minimum value is 20 mm, na? Yes, the answer is 20 mm. 58. Okay, effective span. Simple support beam having a clear span of this. Okay, clear span is given 6 meter. Support width is given 350 meter. And the cross section are 300 and 500. See, nothing is mentioned. Always take this as the effective depth. Tell me the right answer to this. The right answer. You see, it is what? LC plus width and LC plus D, whichever is minimum, right? Whichever is minimum. Yes. Now, now ladies and gentlemen, this width is what? Width of support, not width of beam. This is width of support. That means this is 350. Yes, and this is 500. It's not the width of the beam. It is width of the support. Okay, the answer becomes what? 6350. Remember this thing, don't get confused. Okay, and this is 6000 actually mm. Yes, understood. Next question, 59. For a RCC beam, the maximum area of tension reinforcement. Very straightforward question. Please tell me the maximum area of tension reinforcement. Water got finished. For a 59. Come on, we are going slow. Drink water and or eat some food and answer fast. Answer is 6000. The maximum reinforcement is 4% of BD, right? Gross area. 4% of gross area, right? So this is 4 by 100. It's a small b, suppose. 300 into 500. How much are you getting? You are getting 6000. Okay. Understood? Simple straight calculation. Yes. Tensile strength of concrete is neglected in which limit state? Tensile strength of concrete is ignored in which limit state? Means tensile strength ignored means what? All the tension is taken by, indirectly means what? All tension taken by steel. All tension taken by steel. Yes. In both limit state of compression means what? For columns and beams, it is assumed that all the tension is taken by steel only. Okay. Question number 61. When mild steel is replaced by HYSD, then what happens? When mild steel is replaced by HYSD, then what happens? Answer fast, answer fast, answer fast. We are 61, 39 to go. Let us see, can we complete before 12 o'clock? Bond stress increases by 60%. When it is from tension to compression, then 25%. Next question. Okay. The strain due to creep is this one. Okay. Modulus of elasticity is this one. The total loss of pre-stress due to creep and shrinkage in the pre-tensioned beam. What is loss? Pre-stress loss means stress loss. Stress loss is what? Strain into modulus of elasticity of steel, right? This is the loss. Now tell me the right answer. See, written loss due to creep and shrinkage. Don't jump. Don't jump. Chidi out nahi hai. Don't jump. See the question. Read the question properly. Are you not reading the question properly? Are you not reading? It is written creep and shrinkage both. Now answer. I'm telling you, don't jump. It is written creep and shrinkage both. Creep is how much? It is, can I say this is 2 in 10 to the power minus 4, right? Yes, this is due to creep. And shrinkage what? 3 to the power minus 4. It is not given. We should know, na. Total strain is how much? 5 into 10 to the power minus 4. So this is the total strain and multiply ES, that is 2 in 10 to the power 5 Newton per mm square into this strain. Okay, so now what is the answer? Now tell me. Now what is the answer? Arey Basu, how it is 50 Baba? 200 hai na? Arey it is 200. Simple calculation, you are doing mistake. It is 5. You saw 550. It is 200 na? Yes. So answer is what? 100 MPa. Okay. So see, very simple question, but you have to be little alert sometimes. I don't think that every question is, you know, some silly mistake. 63. Deflections are controlled by 21 minutes, 37 questions. Let us see, can we do it? Deflections are controlled by what? Very straightforward question. Span by depth ratio. Span by depth ratio. Now answer this. I have already discussed this. Maximum span by depth ratio for a two-way simply supported having Fe 415 steel. Answer this. Let us see. See, first of all, two-way simply supported. Two-way simply supported for mild steel is how much? For mild steel it is 35, right? But it is 415, so HYSD, so I have to multiply what? 35 into 0.8. That is what? 28. Arey Baba, sab answer de diya. 32, all 28, 32, 35, 40. No, answer is 28. Read properly. See, it is simply supported, na? See, if it was continuous for mild steel, it was how much? 40, yes, and for HYSD will be 32. Now clear? Now everybody is clear? Now will not commit mistakes. Little alert you have to be. Question number, this is two-way simply support FE415, right? Yeah. Understood? Okay. Next question. Strain distribution in concrete in the immediate state of flexure. Very straightforward question. Strain distribution, not stress. Strain distribution. Strain distribution is what? Strain distribution is always linear. Strain distribution is always linear. Parabolic constant बोल रहा है बासु, सो गया है वो. Stress distribution नहीं है बाबा. Strain distribution. Strain distribution is always linear. Stress distribution is parabolic and that constant thing. This is stress. This is stress. This is what? Strain. Strain is always linear. Okay. Question 66. Stirrups are provided to resist what? Stirrups are provided to resist what? Stirrups are provided to resist what? Resist diagonal tension only. Stirrups only resist diagonal tension. They don't resist diagonal compression. And therefore tau v should be less than tau c max. You see, tell me, if tau v is less than tau c, it is what? Safe in diagonal tension. So therefore we don't provide stirrups, we provide only what? We provide only what? We provide only minimum shear reinforcement, right? When tau v is greater than tau c, it is not safe in diagonal tension, right? It is not safe in diagonal tension. So what we do? We provide stirrups. So stirrups take care of diagonal tension. If tau v is less than tau c max, it is safe. What? Safe in what? Safe in diagonal compression. So no problem, no issues. Okay. But if tau v is greater than tau c max, then we can't do anything. We have to redesign, right? We have to redesign. We cannot counter this by what? See, when tau b was greater than tau c, we were providing stirrups and we're okay, no problem, stirrup will take it. Yes. But when tau v is greater than tau c max, we can't do anything. You have to go for redesign. We have to go for redesign because it becomes what? Unsafe in diagonal compression. Okay. So there is no option of diagonal compression being taken by the stirrups. Understood this thing? Understood? The answer is only diagonal tension. The slenderness ratio of a RCC column is 6.5. It is designed as what? It is designed as what? Slenderness ratio of a RCC column is 6.5. It is designed as what? Yes, it is designed as a short column. Yes. So slenderness ratio, if it is less than 12, it is short column, right? Short column. If it is less than 3, then it is pedestal, right? It is pedestal. More than 12, that means what? Long column, right? Next question. Okay, so we know that we have the span by depth ratios, right? We saw many span by depth ratios, 7, 20, 26, 30, 40, 35, 40, all these things we saw. So we multiply certain modification factors. Okay, so what are those modification factors? So which of the following is not a modification factor? Is not a modification factor. What is the answer to this? We have 3 modification factor in fact. So what is which modification is not there? The answer is D. There is no modification factor for torsion steel. We have modification factor for tension steel. We have modification factor for compression steel, and we have modification factor for flanged beam. It is a flanged beam. Okay, but we don't have any modification factor for this torsion thing. 29. Okay, the friction loss in a post tension beam with a straight tendon. Okay, the friction loss for a post tension beam with a straight tendon. See, the friction loss is what? It is P initial force into what? Into mu alpha plus K into X. right? And here it is written straight tendon. Straight tendon means what? This alpha is 0. Yes, because there is no change of slope, right? See, alpha indicates what? The change of slope, right? But there is no change of slope. There is no change of slope, right? So therefore it doesn't depend on this mu alpha term, because mu alpha is 0. Because see, mu is there, friction is there, but alpha is 0, na? Straight tendon. For straight tendon, alpha will be 0. Answer is what? Only depends on k into x. Understood, everyone? This small concept they have asked question. 70. One-way slab, the main reinforcement is provided along. In a one-way slab, the main reinforcement is provided along. Along means parallel, we can say. Along means parallel, we can say. Parallel. Parallel to what? Yes, shorter span. This is the main reinforcement. Yes. And this is what? This is the distribution steel, right? This is the distribution steel. So distribution steel is provided along the longer span for one-way slab, and the main reinforcement is provided along the shorter one. Yes, along the shorter one. Remember this. 71. Okay. Something's on the ties. Ties. Yes. So if you know this question, answer this. See, this is the diameter of the tie bar at the rate. This is the spacing of the tie bar. So to find out diameter and spacing. Diameter is, minimum diameter is what? The minimum diameter is maximum of two values I told, right? You have to take the 5 by 4 and 6. And the spacing, maximum spacing will be the minimum of three things. Minimum of three things. One is what? 16 into 5. Okay. Then 300. Then your least lateral dimension. So here the least lateral dimension is how much? You see 350, 350. So least lateral dimension is 350. Now here when you are taking the 5, here we take the maximum 5, means what? 25. We take what? 25. And here we take the minimum 5. Okay, you see maximum, maximum. You take the minimum 5. Minimum 5 is how much? 16 here. Understood? Yes. So now you see what happens here. Now what happens here. So here the minimum size is 6.25, right? Minimum size is 6.25, and the maximum spacing, this will be 256. So 256, this and this, maximum spacing will be 256. Now answer me. If this is the minimum diameter and that is the maximum, minimum diameter is 6. So these two gets cancelled, right? Because there are 6. So minimum diameter is 6.25. Take more than that, right? Now the maximum spacing is 256. So it cannot be 350. The answer is D. Understood everyone this question or not? Tell me. Everybody understood this question or not? Tell me. Everybody understood this question, how to answer this type of lateral ties question? Any doubt in this? Clear? Okay. See, minimum diameter means maximum, right? Maximum spacing means minimum. Here minimum means here also minimum. Here maximum means here also maximum. Okay. Because it is 6, minimum diameter is 6.25 na. So take more than that. Understood? Minimum is 6.25. So you have to take more than that. So you cannot take 6. Take 8 or whatever. Okay. Next question. Question number 72. Okay. Percentage loss. Percentage loss, slip loss. Slip loss. Now slip loss is what? Slip loss is the slip amount by the length into 100. Because this will be the strain, na? Not strain, 100 is ES. See, what is loss? Loss of pre-stress means strain into your modulus of elasticity. This is the strain, right? So slip is 6 mm. Okay. Length is how much? 30 meter. So to find out in strain in unitless, na? So it is 6 mm means I have to take in mm only. Yes. So strain. Strain into modulus of elasticity. 2.1 into the power 5. Yes. So this is the slip loss. How much slip loss you are getting? 42 na. We are getting 42 Newton per mm square. This is the slip loss. Now the slip loss percentage. So slip loss percentage will be what? Percentage will be the loss divided by the initial stress. That is what? 1000. And this into 100. So I am getting how much? 4.2. Understood this question? Now see, such kind of straightforward numericals also they will ask in the examination. Therefore, I have given few numericals also. Yes, I have given few numericals also. Next question, 73. Okay, see these questions we solved actually a few days before. I have put here. Why I have put here? Because I want to emphasize the fact that in the state exams also they will ask you some straightforward numericals. Okay, in the state exams also they will ask you some straightforward numericals. Don't leave numericals. So see what is asked, limiting value. So MR limiting formula is what? Simply 138 FCK BD square. Why? Because you see FE 415 still is given, right? If this was for FE 500, this becomes how much? It becomes 0.133, right? And for FE 250 it becomes what? It becomes 0.148. But here it is given FE 415, so this directly you can find out this value. So this is what? 0.138. See, all one-liners, all one-line questions, all one-line questions. So 138 into FE this M20, and then what? 200 into 500 square. This will be in Newton mm, so divided into per 6. I'll get the answer what? This 138. I'll get what? 138. Understood? So why I wanted to put these questions? Because I want to emphasize that in the examination they will ask you straightforward numericals also. So all this kind of one-line numerical. Okay, any subject you are studying, one-line numerical you should do and go. Don't leave numericals thinking that no they will not ask. Okay, and don't do long numerical also, like solving big questions, not required. 74. Okay, I answer this question. We have very less time, 8 minutes. Come on. For this column, limit state of compression, what are the strains we take? This is the strain, this is the strain, and this is the condition of loading. Any idea about this? I have taught, my old students will be knowing at least, but if you have idea, if you have studied from somewhere else, also no problem. What is the answer to this? Let us continue till studio is there. I am enjoying. Let me reduce the AC. Mode is what? Yeah, little chilled. Will make it little chilled. How to know? Now the sound reduced. Answer is C. Yes. Pure axial loading is 0.002. Yes. With no tension it is what? 0.035 minus what? 0.75 of the minimum strain. Yes. And with tension means it becomes a beam. With tension means what? It becomes a beam. So 0.0035. So I can say 241. Answer is C. I should answer correctly. Very good. 75. The effective span for a cantilever beam is how much? Very good, Akars. So what is the effective span? What is the effective span for a cantilever beam? Yes, it is clear span plus effective depth by 2. See. 76th question. Okay. This is from footing, right? This is from footing. One side we have the stresses and here we have the critical section. Answer this question. You see, I have covered almost all the important things, right? So please do attend these sessions. If you are attending the sessions, I can guarantee you that many questions will be asked from these sessions only. So what is the answer to this? See, one-way shear is at D distance, punching shear is at D by 2, and bending moment is at face of column. You see, this is the suppose footing, this is the column. So here we have what? One-way shear. And this is how much? This is D. Yes, one-way shear, right? This section we find out what? At this section we find out the bending moment, right? And at a distance of D by 2, okay, and two-way. So here D by 2, here D by 2, here D by 2, here D by 2. This is what? Here we find out what? The punching shear. So I can say 231. Answer is D. Question 77. Okay, net downward load when we have an arrangement like this from pre-stressed concrete. In this, we know that we will have a upward load. And what is the upward load value? PE by L. This is the upward load value, right? Remember this, PE by L. Yes. So P is how much? This is the P. P means what? The pre-stressing force. So 500 kilonewton into E is how much? 100, and L is how much? 20 meter. But you see, I have to mention in mm, because this is in mm, this is in mm. This will get cancelled. I'll get the answer in what? Kilonewton. So what is you are getting? This value, how much you are getting? If you are getting how much? This is 0, 0, 0, 0, 0, 0, 0. How much you are getting this? Sorry, 4, 4. This is 4. Sorry, I forgot this term 4. 4 PE by L. Sorry, 4 PE by L. 4 PE by L getting how much? You are getting 10, na? 10. Yes, the load is inclined. Yes, the load is inclined, obviously. Yes, getting how much? 10. Yes. So 10 already is acting up. 10 is acting from below. It is, load is balanced perfectly. So answer is what? 0. So remember this. Whenever we have, okay, this triangular profile, yes. So upward load is how much? 4 PE by L. Yes. And when we have, parabolic profile, then it is what? The upward load will be what? 8 PE by L square. This will be the upward UDL. Right? 8 PE by L square, what is at the upward UDL. Understood? 8 PE by L square. Understood? So this thing you should remember. Next question, 78. Okay, development length for a bar under tension is 400. What is the development length for same bar under compression? Answer this question. I just give you the hint that your development length is inversely proportional to bond stress. Right? The development length is inversely proportional to bond stress. Inversely proportional, na? So when it changing from tension to compression, the bond stress will increase, na? Yes. The bond stress will increase, na? Bond stress increases how much? 25% increase, na? 25% increase, na? So now tell me what's the right answer. Why everybody is writing C? It will be D, 320. It will be D, 320. Bond stress increases, na? So development length will decrease, na? Yes. Yes. You see, LD is inversely proportional to tau B. So suppose I am telling LD in tension was inversely proportional to 1 by some tau BD. Yes. So now LD in compression will be what? It will be 1.25 times of tau BD, na? Yes. Yes. Or I can say LD tension by LD compression. Sorry. LD tension by LD compression. You can solve a common. Why it is not writing here? Sorry, I'll write down here. LD tension by LD compression is what? It is 1.25, na? You see? Or I can say 1.25 tau BD by tau BD. Yes? Inversely proportional. Tau BD get cancelled. I can say here LD compression is equal to whatever tension you are getting, 400 divided by what? 1.25. That is how much? 320. Understood? Understood. It's a very simple question, but you get confused. Yes. So what I told that with from tension to compression, bond stress will increase. Bond stress increase means it will decrease only, na? Okay. What you did, you directly multiplied 400 into 1.25, and they gave an option also. Yes or no? They gave one option also. You thought, okay, 25% increase, but 25% increase in not development length. 25% increase is not in development length. It is increase in what? It is increase in the tau BD. Next question, 79 question. Okay. Answer this question, very straightforward question. If the span of a continuous beam is 13 meter, what is the allowable span? This we have already discussed in one class. Okay, repeat telecast. Good afternoon. What is the answer to this? 20, we have already discussed this. Yes. So Actually it is 26, but that is for less than 10 meter. For more than 10 meter, 10 by span we have to multiply. Yes, multiply 10 by span. So this becomes what? 26 into 10 by 13, that is how much? 20. Actually it is 26, but this is for what? Less than 10 meter. But if it is more than 10 meters, you have to multiply 10 by span. 80 question, straightforward. What is the ratio of the flexural strength? Ratio of the flexural strength means what? FCR and the characteristic compressive strength FCK for F25 concrete. Answer this question. Flexural strength, nothing is mentioned, means you have to go for what? You have to go for your FCR, means what? Your, we can say flexural tensile strength, or I can say modulus of rupture. What is the answer to this? Very straightforward. This is 0.7, this is actually 3.5, nah? 3.5, na, 0.7 and all, and this is 25. So how much are you getting this? You're getting D, na, 0.14, na? Yes, 0.14. See, this is the 0.7 root FCK, right? So I can say 3.5, okay, straightforward question. 81. Which of the following losses is a long-term loss? Which is the following loss a long-term loss in post tensioned concrete beam? Anyhow, the post tension long-term loss happens everywhere, right? So it happens in pre and post also, no problem. So which of the following is a long-term loss only? What is that? Is only asked. Which of the following is a long-term loss? Yes, relaxation to steel is what? It's a long-term loss. Relaxation steel, that is what? Long-term loss. Anchorage slip will occur quickly. Friction loss will occur quickly. And even if there is something elastic happening, that will also occur quickly. 82nd question. The distribution steel in a one-way slab, okay, with Fe415 steel and its maximum spacing is how much? Answer this. What is the distribution steel amount and the maximum spacing for distribution steel? It is HYSD, by the way. Arey Baba, padha, question padho. For mild steel it is 0.15. For HYSD it is 0.12. So 0.12, and this is distribution steel, so 450. Right? 450. See, for main steel it is 300. For this is 450. 83rd questions. If the dimensions and grade of concrete are restricted, the beam is designed as. If the dimensions and grade of concrete are restricted, the beam is designed as what? Why L beam here? Doubly reinforced beam. You see, when we see if MU is less than MOR limiting, yes, then we go for singly reinforced, means singly under reinforced beam, no problem. Yes. Now what is this MOR limiting? 0.13, suppose 138 or 143, whatever, or 133, whatever, into FCK BD square, right? So if you want to keep the MU less than MOR limiting, then what you can do? Either you can increase the FCK or you can increase the dimensions, right? Dimension, depth or width. But suppose that is restricted, you cannot increase. B hona chahiye. B hona chahiye, but you have to understand the context of the question. That at what context they are asking you, right? Okay, at what context they are asking you. Yes, so they are asking you that, you know, the context is this, that you cannot increase the FCK, cannot increase dimensions. If you cannot increase, then what will happen? There will be a moment which will be greater than what? MOR limiting. Then there are no options but go for what? You have to go for what? Your doubly reinforced. To go for your doubly reinforced. So in this context they are asking. Okay. New maximum coding, new code. Okay. Send me the picture, number. I have not seen if it is changed, so we'll change the thing, no problem. Send me the picture. I'll also search, but send me the picture. Okay. Next question. 84th question. When the depth of neutral axis is more than limiting depth of neutral axis, what happens? What is this? Very straightforward question. When the depth of neutral axis is more than the limiting depth of neutral axis, what is the answer to this? Very straightforward question, over reinforced beam. Very straightforward question, over reinforced beam. XU is greater than XU limiting. Okay. 85th question. The modulus of elasticity of M25 concrete. See, it is more. XU is more than XU limiting. So over reinforced, right? Yes. Same, na? Depth of neutral axis is more than limiting depth. Over reinforced. Yes. Okay. The modulus of elasticity, direct question, and nothing is mentioned means you have to go for the short term modulus, right? Nothing is mentioned means go for the short term modulus. Very straightforward question. Okay. So 5000 root FCK. Yes. 2500. Okay. Okay. The maximum compressive stress. Yes. This is a pre-stress concrete. The maximum compressive stress. See, the compressive stress, extreme fiber stresses are what? P by A plus minus M by Z plus minus PE by Z. Right? This is the formula. Now see, loading is not given. When the load is not given here, see, when the load is not given here, I cannot find out the moment, right? Load is not given, nothing load is given, so we cannot find out the moment. So we ignore this. Okay. So in this plus minus, maximum will be when it is plus, right? So we'll take the plus. So indirectly they're asking you this one, P by A plus P by Z, the maximum compressive stress, right? So P is what? The pre-stressing force is given 400 kilonewton, convert into Newton. Area is how much? Area is 200 into 400. Yes. This is 5 plus PE by Z. So 400 into 10 to the power 3. E is given how much? Eccentricity is given 100. Okay. Divide by your Z. It's a rectangular beam. So BD square by 6, right? BD square by 6. B is B D square by 6. So cancel. 5. 2.5. How much are you getting this answer? Is 7.5, na? Yes. These are getting 7.5, na? Yes. So total answer is 12.5, right? Understood how to solve this question? हाँ, dead load consider करना चाहिए, but this is state exam. This is not mains paper. Okay? Okay, this is not mains paper. Okay, so dead load कितना consider करना चाहिए और ऊपर से ऊपर से this is time restraint. Okay, so you might have studied from someone who is preparing you for mains. Okay, so there are some teachers who directly teach for mains. They are very great teachers. I call them pothi. Okay, so what happens when those students give state exam? They are not able to clear the state exam because they don't understand with what context the question is asked. You have to understand the examination. And many people do that. I have seen people studying from, big institutes in Delhi, Hyderabad, preparing for mains. Directly in RCC, they prepare for mains. Directly they design, let me spend some time in this little roasting I will do now. Directly they teach for mains. They are great Swamis and they are great Pandits. Okay, so what they do, they will, I should not tell Swami and Pandit, that is insulting to the real Swami and real Pandit. I will tell them actually Pothi. Pothi is the best word. Okay, so what they do, they will teach you directly mains. They like directly they will start teaching design beam, big things. They will teach you WSM 6 lectures. They will teach you WSM 6 lectures. They will teach you design, WSM flexure design, shear design, WSM flanged beam 2 lectures, WSM doubly reinforced beam. Find out the MOR. They will teach you find out the MOR of this. They will teach you to find out the MOR of this beam. One reinforcement is here, one reinforcement is here, one reinforcement is outside the beam. Okay, considering the effect of this reinforcement here and effect of this here, and like this, they will teach you. Student is very happy. He feels that I am on the site and and I am doing great things. And the examination, but you have to prepare, and they never clear prelims also. Examination, they will ask you what? Simply support beam, continuous. Okay, what is the allowable? No, I will not comment about the name you have mentioned. He is a great teacher, as per me. He don't do this. He don't do this. What happens, he don't do this. He's a great teacher. The name you have mentioned is one of the greatest teachers in India. Okay, I will tell that. Okay, so he don't do this. What happens? People copy from the notes. What happens, many of the teachers in India, they don't have their own notes. They copy from notes. Okay, so they refer to some institutes and their notes they copy. Okay, from their notes they copy. But the thing is that those teachers don't teach from those notes. They don't give their notes. Okay, then they copy from the books. Okay, now there are so many teachers who were born in the lockdown. I tell them lockdown born teachers. so they do this. Okay, so let us not waste our time there. Okay, so coming back here, I will tell you, when you are studying RCC, steel structures, even structural analysis, okay, okay, that's what I told. The name you mentioned, he is one of the great teachers. He don't do this. He don't do this. Other people who are trying to copy, they do this. Okay, let us come back here. So here, okay, so here what happens? Here what happens that we have to understand the context. Since this is a state exam, you don't have to consider the dead load. Yes. So we have to find from dead load. See, if you find dead load to be lengthy, you can find dead load. See, this is B, this is D. I can assume gamma C is equal to 25. Yes. And then I can find dead load. But that is to be lengthy. That is to be done, assumption and all, for your mains paper, not for prelims paper or objective paper like this. Here, keep it very straight, simple. Okay, keep it very straight, simple. Okay, so P by A plus P by Z. This for this PDF, what you do, you message me on my number. Okay, I will connect you to the team. Okay, they will provide you the link. Okay, also it will be available in the smart list, but I have been maintaining a list of the YouTube lectures I have taken. So if you want, you message me, I will connect you. Okay. Okay, and if somebody has got offended by my telling this thing, then that's very good. Such things should be offended. This thing is wrong. This approach is wrong. Yes, you cannot study RCC in this way. If you study RCC in this way, yes, if you study in RCC in this way, then you will never be able to clear the examination. You have to understand that you are preparing for which examination, what is the context of the examination, yes, and then you can answer. Yes. Okay. My way of teaching is like some sir. Okay. I am honored. I am honored. I am honored. I don't consider myself equal to him or someone. Okay. I am honored that you is like, if you say is okay, but I am honored, but I say I am less. I am still in the learning stage. Okay. Learning stage, and I will not equal him or anyone. I can say that, you know, some people are, we cannot be equaled, right? So he is someone we cannot equal. Yes, he is someone who is cannot be equaled. So I will not tell that I will equal him or like him. Okay, okay, because I have a lot of respect for him. Okay, next thing. In the reinforced concrete on soil, the minimum thickness at the edge should not be less than, this is a very straightforward question. The minimum thickness at the edge should not be less than A, 150. Very good, straightforward question. Answer is A. Okay, we are going very good. 87 questions and people are interested. Okay. Okay, this question we have discussed, right? How to decide a beam is singly reinforced or doubly reinforced. What I told, compare MU and MOR limiting. Okay, so if MU is less than MOR limiting, it's a singly reinforced beam. Singly reinforced beam. Enough of my discussion, enough of my prejudice. Okay, this lecture is not about my prejudice. This lecture is about what? This thing. Yes, and another thing I will tell that a teacher is always by the students. The students, here you see all of you are very attentive. That is making me teach nicely. So students matter. Yes, students matter. So you all are good students, you are answering the questions, and therefore I came with 100 questions. Suppose you people were not answering the questions, tell me, I would have continued till 100 lectures or 100 questions, or just solved 40, 50 and went. I would have solved 40, 50 and went. Na? Why I am able to solve 100 questions? Because you people are attentive, you are answering the questions, you have come prepared. Yes. So students make good teachers. And therefore I choose my students. I always choose my students. Okay, so you are all good students. Thank you very much. Mu less than equal to MOR limiting. So here is mu is how much? Mu is 150 you see. And what is MOR limiting? And find out MOR limiting. How much MOR limiting you are getting? MOR limiting is 1, it is FE 415 na, 138 FCK BD square. So how much you are getting? This question we solved in a different lecture, in GATE lecture, but I put it here because this can be also asked in state exam because it is straightforward. Straightforward, right? Straightforward. 132.5. So such straightforward questions they will ask in the examination, okay? Sorry, kilonewton meter. So it is what? It is a doubly reinforced. Why? Because you see your mu is 150. It is coming what? Greater than MOR limiting. You see? It is coming greater than MOR limiting, right? So the external moment is greater than MOR limiting. It becomes what? Doubly reinforced. Okay. Okay. आप डॉट देते हो सर. डॉट मतलब what is dot? Okay, next question, 89th question. In a spiral reinforcement, okay, spiral reinforcement or helical reinforcement, when we are going for spiral or helical reinforcement in the core, then tell me this. गुस्सा करते हो? हाँ, गुस्सा करना चाहिए. गुस्सा करना is good. Yes, if you feel everything is okay, then you know, अच्छा डांट बोल रहा है. Okay, आप डांट देते हो. Yes, that is my job. If you are going in the right, you are going in the wrong direction, and if I am not correcting you, then that is not my, that is not my style of learning. My style of learning is, if you are going in the wrong direction, I will stop you, and to stop you, if it is required that मुझे अगर डांटना पड़े तो मैं डांटूंगा. मैं पीछे नहीं हटूंगा आपको डांटने से. यस, और अगर मेरे डांट से आपको ये लगता है कि बुरा है तो फिर आपका प्रॉब्लम है. यस, क्योंकि मेरे डांट का इंटेंशन ये होता है कि स्टूडेंट गलत डायरेक्शन में ना चला जाए. Student don't go in the wrong direction. Yes, there are enough people who are misguiding by emotional things. Okay, na na ne nare nare na nare 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 na. So I don't do this na nare 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 na. Yes, I can't bring musical effects and that all this emotional melodrama I can't do. Yes, I am very straightforward, and the straightforward thing is that all of you will have lot of exams next year. Yes, and next year there will be many examination. Already you can see that TSPSC exam notification is out, 2300 vacancies. JKSSB is out, 800 vacancies. There will be vacancies in UP, Chhattisgarh, Tamil Nadu, Karnataka, Kerala, Odisha, Gujarat, Rajasthan, West Bengal, and if some state I miss, pardon me, but every state is going to bring up vacancies. Yes, and therefore I am conducting these sessions so that you get ready beforehand. Many people what they do, when the notification comes, they start preparing. No, we should not wait for the notification. We should start preparing now only. Right? We should start preparing now only. When the notification comes, we are already ready. Yes or no? That time we'll revise. Yes. So that time we'll revise. So therefore, all the students I am requesting, all these sessions which I am conducting, you can see, tell me, everybody whoever attending this session, tell me. This session of RCC till now we have solved 89 questions. Yes, solved 89 questions. Tell me, everything is designed for the state exam or not? Tell me. Everything is designed for state exams or not? Yes. State exams and SSC JE and GATE 1 mark questions and ESE prelims questions, right? So it's a very nice blend and balance, right? So please attend. And another thing, I'll tell you, okay, I'll tell you one beautiful thing, okay? So we are talking, let us talk. I'll tell you another beautiful thing, that I call my professors and school teachers and tell them what I am doing, and please correct me if I am doing something wrong in my lives. And sometimes my professor scold also, "Arey, what you are doing this nonsense? This is to be done not like this, do like this." Yes. Currently I am taking a course from IIT Madras in data science. I regularly call my mentor and ask that I am doing this. They scold, "Arey, what fool, what you are doing this? You are writing the wrong code, you are using the wrong language here." Wrong language means not this language, means the language of coding. Yes. So thing is that whenever somebody scolds you or corrects you, it's good. अगर कोई आपको मक्खन लगा रहा है ना, somebody is buttering you, then remember there is something fishy. Yes, teachers are not supposed to butter. Teachers are supposed to show you the truth. Even if the truth is what? Even if the truth is little harsh, it is better to realize the harsh reality and then correct yourself, so that when it comes to the examination, what they will do, many people what they do, they will butter you, and when your results are wrong, they will again butter you, but never tell you that where you are going wrong. Yes, where you are going wrong, that is very important. So sometimes I might scold you, or I might tell you that this is wrong, you are not doing correct, this is not the way, don't study like this, do like this, don't study in that way or this way, and that you should take as a what? Blessing of God. It's a blessing of God. Not I am not God. I am not God. Certainly I am not God. I am not those so-called gods of civil engineering. I am not God of civil engineering. I am still a student of civil engineering. I am also learning. I can say that I am 30%, you are 15%. Yes. I am 30%, you are 15%. Tomorrow you might be 50%, I will be 30%. I will learn from you. Yes. Suppose many of you are selected in ESE or state exams. You will learn also many things. I will also learn some things from you. Yes, that time you will be experienced. Yes, so I am certainly not a god of civil engineering, but yes, I am a teacher of civil engineering. And as a teacher of civil engineering, it's my duty that I scold you, I correct you, and bring you to the right path whenever it is needed. Okay, sure. So answer is what? Triaxial compression. Next question, 90 question. The stress strain curve adopted by IS 456. This is what? The stress strain curve of concrete adopted by IS 456. Yes, now it is correct. Parabolic up to a strain of how much? Up to a strain of 0.002. Okay, and then it is constant. Yes. C. 91st question. Okay, very good question. It was asked in ESE prelims. I have put it here. The sigma CBC, this is what maximum bending stress means what? This is sigma CBC is given as 8.5. The short term and long term modulus. Okay, short term modular ratio. I'll answer this question. Okay. See, short term means, short term modulus means what? ES by EC, right? Yes, ES by EC. Now ES is what? 2 × 10⁵. You should remember this thing. I told you. Modulus of elasticity of steel. Now EC is what? EC is 5000 root FCK, right? Short term. Short term EC is this one, right? So this becomes what? 2 × 10⁵ divided by what? I can say 2500. So how much you are getting? You will be getting 25,000. So you are getting 2 lakh by 25,000 what? 8. This is fine. Short term modulus. So short term modular ratio. When you find out the long term, then what happens? When you find out long term, this will be 2 × 10⁵ divided by 5000 root FCK, and then further divided by 1 + 5. Further divided by 1 + 5. But the thing is that I don't know phi. I don't know phi, right? So I cannot find out in this manner. So I can find out using the WSM method, that is what? 280 by 3 sigma CBC, because this particular modular ratio takes into account the long-term effects. Yes, this particular modular ratio takes into account the long-term effects. So if you find by this, you will get approximately how much? 11 your modular ratio. So answer is what? 8 and 11. So it's a good question. So remember this, they can ask you in state examination, right? So short-term modulus you can find out this way. Directly put ES by EC, and long term you can find out in this way. Okay, understood? Next question. 92. In a cantilever retaining wall, the main reinforcement is provided where? In a cantilever wall, where it is provided? Tell me. A, B, C, D. See, when the backfill is exerting pressure, mostly active pressure, it will be away. So it will bend like this, right? So tension will be developed here. Yes. So we provide the tension steel somewhere here, right? On the backfill side in the vertical direction, right? We don't provide horizontal. See, it is written main reinforcement. See, on the other side we'll provide a distribution steel, right? It is mentioned what? Main reinforcement. So on the vertical side only, right? Understood everyone? Yes, understood everyone? Yes. Next, 93. It is asking find out XU, depth of neutral axis. Okay, UC is equal to T. I have solved this question a few lectures before. C is equal to T. Yes, and XU will be how much? It will be 0.87 Fy AST by 0.36 FCK into B. So solve this question. You can solve this question. I have already solved. The answer will be 121 you will get. I have solved this question a few lectures before. So 121, this is 1000. You can just put the values. 1000, this is what? 250. Fy is how much? Fy is 20 and this is what? 250. Okay. So you can solve this, you get 121 answer. Okay. How to remember this formula? Again I will tell. Why I am telling this? Because again a straightforward question can be asked in your state exam. Don't think that in the state exam they will not ask you numericals, but it will be straight. 94. Okay. Depth of footing. What is the formula for depth of footing? The stress into divided by gamma 1 minus sine phi. Okay, this is the formula. If you remember this formula, 1 minus sine phi by 1 plus sine phi whole square. Now Q is your bearing capacity, given as how much? 120. Yes. And gamma is given how much? 18. So this by 18. Yes, 18. See, this is in kilonewton per meter square. This is kilonewton per meter cube. So answer will come in meter. 1 minus sine phi. Sine phi is given 30. 1 minus sine phi. Sine 30 is 0.5. So 0.5 divided by 1.5 whole square. I can say 1 by 9. So this is what? 120 by 18 into 9 square will be 3 square will be 9. So how much are you getting this value? 40 by 54. I can say 20 by 27. I think approximately you'll get 0.74, right? 0.74. This formula is asked a lot, okay, for depth of footing based on the bearing capacity and unit weight. Yes, the answer is 0.74 meter. This formula is important. They ask you in many examination this. Okay, remember this formula. Yes. Next question, 95 question. The bond between steel and concrete is due to what? The bond between steel and concrete is due to what? 6 questions to go. So I talked in between, otherwise would have completed by this time, but it was required. Sometimes it's required. D. Yes, all the 3. Yes, all the 3 are reason. See, they have not mentioned which. See, in plain bar what happens? There will be this adhesive resistance and the frictional resistance. In deformed bar, what will happen? Some concrete will be stuck here. So there will be mechanical resistance also, adhesive resistance also, frictional resistance also. But they have not mentioned now which one. They have not mentioned now which one. So I will choose both 1. See, if it is plain bar, then only 2 and 3. If it is HYSD bar, this is what? 1, 2 and 3. Yes, but nothing is mentioned, so I will go for this 1, 2, 3. Now you see what is this written. A beam is likely to fail due to high bonding stress. Then the bond strength is increased economically by what? By providing vertical stirrups, increasing the depth of beam, providing smaller diameter bars in more numbers, or providing larger diameter bars in less numbers. What is the answer to this? So which one you will choose? You will choose this one or choose this one? Obviously you will choose what? This one. Why? Because for same area means what? Cross section area. Same cross section area. This area and this area will be same. For same area, this will have more perimeter, right? More perimeter means what? More perimeter means more surface area. See, this is cross section area. Same cross section area, more perimeter, more surface area. Because for surface area, we will take the length into consideration, right? So more surface area. So answer is C. Question number 97. Okay, big question. This is homework. Huh? Read the question and do the homework. Okay, one homework at least I should give. So this is your homework. Okay, 97 question is homework. 98th question. What is the answer to this? The modulus of elasticity. This is which modulus? Tangent modulus, initial tangent modulus, second modulus, or chord modulus? Which answer this? 97 is homework. What is the answer to this one? It is your initial tangent modulus. It is your initial tangent modulus. Next question, 99. Bearing strength. What is bearing strength? Bearing strength of concrete is 0.45 FCK. Okay. Bearing strength of concrete is 0.45 FCK. So answer me the question. Bearing strength of concrete is 0.45 FCK. What is the answer to this? Very good. M20 this. Straightforward questions. Straightforward questions. 100. Last question. Limiting amount of steel. AST limiting. Yes. So AST limiting you can find out what? From the formula C limiting is equal to T limiting. I have already explained in one lecture. So 0.36 FCK XU limiting into B will be equal to 0.87 FY AST limiting. Even we solved this question in the GATE session. Okay. So straightforward questions like this they can ask also. Okay. So from here I can say 0.36 FCK is 20. XU limiting will be how much? 0.48 into D, and B is 300 divided by 0.87 into Fy is 415. If you solve this, you will get how much? D. 1150, around 40 something will get. So 1150. Okay, straightforward questions. So again I told straightforward questions will be asked in the examination. So we completed 100 questions. So I think everything is covered, right? You see, hardly 2 hours we had talks also, I explained also, and we covered almost everything of RCC, right? Yes or no? We covered almost everything of RCC. Yes, that is, you know, that is the benefit of attending such sessions. Okay, that's the benefit of attending such sessions, and I will be regularly conducting these sessions as I have promised. Okay, regularly conducting this session for state examinations. What happens that when we, like many people tell that, you know, if you prepare for GATE, if you prepare for ESE examination, then your state exams will be clear. And that is true, but you have to reorient as per the state exams also, right? Yes, you have to reorient yourself as per the state exams. To study for the GATE and ESE, good. But when you are preparing for the state examinations, you have to reorient. Concept is same, but to reorient your brain, that you have to limit yourself to certain type of questions, and that will only happen if you are attending the sessions or solving the previous questions. So whatever your choice. Okay, so like this, you see, I have conducted many sessions before also. I have conducted for BALE, HPCL, TSPSC. I have conducted a session for geotech, surveying, hydrology, irrigation, steel structures. Okay, and you see, I have conducted exclusive sessions for geotech also, and all these sessions objectives, that is for HPCL or any, tell me, HPCL or TSPSC or anything, all objectives in this similar pattern. Okay, so all these lectures, if will be, you can find also. Recently we conducted, you remember, we solved 60 questions from strength of material, remember, and we solved cement 40 questions. 60 questions or 70 questions, how many we solved? 60 questions we solved, right? Yes, so 60 questions we solved from strength of materials. Okay, and 40 questions from cement. Okay, now all these lecture links I have compiled. Okay, they will be also available in the smart list, but if you want on the list, so you can message me, I will connect you. Okay, you can message me, I will provide you the list of all these lectures, and in free time in free time you revise all these lectures. It will be very helpful for what? For your state examinations and your similar examinations like SSC JE and other things. Okay, now coming back to GATE. So as I informed you that, so 24th December 8 PM, who want the full courses, we are conducting scholarship test. So please register for this scholarship test. See, here I am only solving the questions, I am not teaching everything, right? So the teaching part me and other esteemed teachers have done in the app. There are available recorded lectures, and those who want live lectures also, we are going to start our batches also. So batches are also started, some batches are already started. Okay, so if you want, if you are a fresh student, you don't know anything, you are like, sir, very good, you are teaching good, but I want to avail the everything. So that time you can register for this scholarship test. And as informed, from 3rd we are going to conduct marathon. Okay, so please attend the marathon. Okay, so now today we are running what? Your formula memory test. So today at 10:45 PM, yes, so this is a future series, right? This is future series, will start from 3rd of January. Okay, future series. Okay, but we are also conducting current series. In current we are conducting 2 series. Okay, so first formula memory test we are conducting every Tuesday, Thursday and Saturday. So today 10:45 PM, so Abhinav sir will be taking geotechnical engineering. Geotechnical engineering very important, right? Lot of formulas he will revise. So please do attend today only. Today means 22nd. Today 10:45 PM sir will be taking, yes. And we are solving 500 expected questions, okay, for GATE. In that today 9 PM Richa ma'am will be taking 9 PM. Richa ma'am will be taking what? Irrigation and hydrology. So please attend these sessions, okay? If you are preparing for GATE and any exam. Again I tell, if you are preparing, see, formula test, it will be helpful for any exam, right? Yes, so please attend this session, also attend this session, okay? So thank you very much. It was great connecting with all of you. We had nice 2 hours and we solved 100 questions. I am really tired now, so I will go. Bye bye. Okay, okay, bye. Okay, bye. We'll meet again next week in this TSPSC and state series. I will tomorrow I am not conducting a session. Okay, today therefore I conducted long session. Next week the announcements will come in the channel, so please stay tuned. Okay, tomorrow no class. Next week I will it will be informed to you in the you subscribe to the channel. If you subscribe, it will come. If you subscribe, you come. Okay, so when you want these things, then you message me also, I will inform. Okay, I'll tell you that next week which session I will think and tell. Okay, by that time you can see all the previous lectures. Okay, all these previous lectures you can see by that time, but next time I will be conducting some subject. Okay, or what you can do is that in the comment section, in this video, after the video is over, in the comment section you can mention which subject you want. So what will happen, I will come to know that more students are wanting which subject, then I will go for that subject for next week. Okay, let you give the suggestions. Okay, bye bye. I will have my lunch. I am very tired. Bye.